Hi everyone, my name is Abubakar Ibrahim. I am a final year PhD student at the Institute of Space Science in Barcelona and Autonomous University of Barcelona. I work under supervision of Prof. Nandaria. The title of my PhD is Search for Pulsars and Transients from Multi-Frequency Data, and I'm highlighting as part of a follow-up session for the physics doctorate, the course of 23-24. I'm going to start with few words or introduction about magnetars. What are magnetars? They are isolated neutron star with very strong magnetic field. As we can see from the figure plotting the spin and the spin period derivative for pulsar population, we can see number of population or classes from binary systems and radio pulsars. And here is the location of magnetars with the green triangular. They are classified as they having relatively long period, as you can see, from almost 0.03 to 12 seconds, and large period derivative. Magnetars also are persistent source where they emit persistent emission with X-ray luminosity could reach up to 10 to 31 to 10 to 36 erg per second. Beside their persistent emission, magnetars also show X-ray or transient activities where they emit transient emission in a form of a giant flare, which they are classified the strongest events and very rare event. So far we detected only 3 events of this, where they release a luminosity peak in the range of 10 to 44 up to 10 to 47 erg per second. Short burst also, they are the most common transient activity for magnetars, where they show peak luminosity up to 36. Also, outbursts are the sudden increase of the persistent X-ray flux of the source, and it could reach up to 10 to 36 erg per second. So the work done this course, I have been able to publish a paper on the SGR 1935 in this lattice outburst at the Astrophysical Journal. This source is very famous because of the link with the fast radio burst as a radio source. It went into an outburst in October 2022, and we were able to conduct this study based on this. We analyze or we result timing and also in spectral analysis. Or upcoming, I will show you of the result from this source. I'm just showing you the persistent of the source using XMM data with black and new star data with green. The spectra, and showing you here model we use to fit the spectra, and we use the black body plus power law model, which, as you can see, it fits the spectra very well. We derive a black body of almost constant body temperature of a range of 0.04 keV. The black power law is slightly also a phase coherent timing solution. Here I'm just showing you the residuals of the fitting, and we detected the spin derivative the value of 5 10 to minus 11, and this value actually is almost 4 times larger than the value measured during the first outburst of the source into any. This tell us that during this event, Magnetar turned to show a variable in terms of the spin and the spin down of the source, as well as the energy. The source vary a lot during these outburst activities. I was honored to present the part of the result of this work during the XMM Mystery of Neutron Stars and White Dwarf conference in Madrid. It held last June. And just here is me presenting, and also I'm here in the group. Beside this work, I'm currently drafting an article or working in another source that hopefully going to be published soon. And this is dwarf. It's called ZTF 19. It's a white dwarf with very period of 6.9 minutes. Isolated white dwarf, magnetized. The aim of this work is to measure the upper limit detection in radio. So for now, I'm just looking or searching in the archive from different radio telescopes. Here I'm just showing you the ongoing analysis of the source, where I'm having an archive data from VLA telescope and as well as from a SCAP telescope. And for both, just showing you the location of the source, for example, in the green circle, you can see there is no detection so far, but we were able to obtain at least a flux density of 0.08 millijansky. It's ongoing so far. Final comment about my finishing plan. Currently, I'm writing the thesis. I'm almost with first draft. I'm planning to submit of July next month, or maximum early September, and I'm planning to defend by 3rd of October 2024. And thank you so much for your attention.